In this video, I'm going to show you how to lay out and build a simple model using Netica. I've already begun the model that we've been using in our video. I'm just going to add the last piece to save you time. But here's how it would begin. You open the software, click on File, and you would develop a new file. When you develop a new file, you begin by laying out the table. I've already put 4 of our 5 variables in here. So to put the 5th, I simply click on the node here, move on down to my model, place the node, and because I know that interior erosion is going to influence this new node that I just put in, I add the arrow as you've seen here. I click on the A and I put in the name, levee, underscore failure, because we take no spaces here. And now I put in the different state variables. It could be true that there is failure, and I add new because I want to add a second, or it could be false. And now I'm going to apply that. You notice how the node has changed now. Right now the true and false are 50-50, so I have to set up the probability table. When I click on that, you will notice that over here we have the condition of interior erosion. If there is interior erosion, then the probability of levee failure is 5%. The probability of no failure is 95%. However, if there is not interior erosion, then the probability of levee failure is only 0.01%. and its complement is 99.9%. So I'm going to apply these probabilities and say OK. I will say OK here now. Notice that this has not been updated. I click away from it, and now we're going to go to our network. What we have just constructed here is a Bayesian belief network. You would do the same thing for every variable that you're going to input. Add the variable, use the arc to connect those variables, construct the probability tables, then go to the network and say compile. And this causes the network to calculate all the probabilities. So this is what you've seen throughout the other video here, and now I'm going to show you briefly how this might work. Suppose we learn that a particular levee does not have any root problem. So I'm going to click on false, and you see now the probability of root is 100% false. We now know that is false. There's no longer a probability. Suppose it does have animal tunnels. Now let's suppose that there is interior erosion, but that the inspection did not pick that up. And now we can see here that under these circumstances, the probability of a levee failure is 5%. If I restore these to their original positions, whoops, you can see we get the original failure probability back. And so you could investigate any number of combinations here. False, 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 and false, and you see the probability of levee failure is very small. So this becomes a very handy tool. Now all we're doing is learning the very basics of how to use this software. There's a great deal more that it can do, but for now we'll stop here.